Welcome to 7.2 worksheet go over here. I'm going to try to get as many as I can get done here in the time allotted by my recording format. We're going to use the addition subtraction formulas here. It's good to have those jotted down or have your notes out. Again, sine, cosine, and tangent have these addition subtraction formulas. They're all a little bit different. There are some similarities as well here. So first of all, I'm going to go ahead and break up 75 here into two kind of more common angles from the unit circle. So I'm going to go 30 and 45. Okay. So what that means now is I'm going to rewrite that this is going to be the tangent or the sine of 30 degrees plus the 45 degrees. And again, the sine rule is going to be the sine of the first times the cosine of the second, and plus, if it's plus here, it's plus there for sine, addition and addition. And then it's going to be the cosine of the first and the sine of the second. Again, when you take your quizzes, do your homework, take your tests, you can have your notes or a note card out, so this will be of much help here. So I'm going to go ahead, and these are off the unit circle. So the sine of 30 is 1/2. The cosine of 45 is root 2 over 2. Plus the cosine of 30 is root 3 over 2. And the sine of 45 is also 2 root 2. So when I go ahead and kind of add these up now, again, I know that overall I'm going to get a common denominator of 4. I'm going to have a plus in between from that. And so I'm going to get root 2, and root 3 times root 2 is root 6. Remember our radical rules there. So there is our first answer there. As we move on, I'm going to change colors here. So now again, follow that same procedure here. Cosine 105 is 45 plus 60. So that's one way to do that here. So again, the cosine rule for addition is going to be cosine of the first, cosine of the second, minus, in this case, the sine of the first, times the sine of the second. So again, a little bit different formula from the sine addition subtraction. Again, we're going to go ahead here and do some simplifying here. Cosine of 45 is square root of 2 over 2. Cosine of 60 is 1/2. Those are multiplied, minus the sine of 45 is root 2 over 2. The sine of sine of 60 is root 3 over 2. So again, I'm going to switch back here. I'm ready to kind of simplify this. Again here, 4 in the denominator between the two. I got minus between the two here. And I am going to get root 2 minus root 6 for this one here. Alrighty. I'm going to skip the tangent of 15. I'm going to hop down here to number 9. And with number 9, we have radian units here in pi. I'm going to look at this to be like 4 pi over 12 minus 3 pi over 12. Now again, the key thing here is to get something pi over 12 such that it simplifies to something that's one of our more common angles on the unit circle, like the pi over 3s, pi over 4s, pi over 6s, and so on here. So when I go ahead, I have to switch this around here to make it negative here. So I'm going to rewrite this as the tangent of 3 pi over 12 minus 4 pi over 12 because it's a negative 1 pi over 12. So now I need to kind of simplify this a little bit here, because 3 over 12 gives me pi over 4 minus, and then 4 pi over 12 is pi over 3. So that's kind of the direction we need to go here. So there's a lot of things going on as we work through this. As we kind of go from here now, we have to apply the tangent subtraction. And again, that's going to be the tangent of pi over 4. And since it's minus, it'll be minus tangent pi over 3 over 1 plus these two tangent expressions multiplied. So now the preliminary video had you updating your unit circle to include the tangents values around the circle. So I'm going to go ahead here to the tangent of pi over 4 was root 2 over 2 over root 2 over 2, which is 1, minus the tangent at pi over 3 is going to be root 3. Down here I'm going to get 1 plus the tangent, or the same two values, so 1 times root 3. Now this is kind of a bit of a bear, because now we have to simplify this by multiplying by, since we have a radical on the bottom, we have to change these to binomials, and we have to multiply by the complex conjugate down below, which means I have to do this. So make sure you give yourself plenty of room to do this. Now we have to expand these, so I'm going to get 2 times, oh no, excuse me, 1 times 1 is not 2. I'm going to go back to my blue here, just so if I FOIL this out, I get first times first for 1, then I get 2, my middle terms collect, and here I get a plus 3. Down below here I have a complex conjugate, so I'm going to get 1 minus 3, no middle term. I'm going to do some simplifying here. I'm going to bring this down this way. I'm going to get 4 minus 2 root 3 over negative 2. Bringing that here, doing a little bit of dividing here. 4 divided by negative 2 is negative 2. And over here I'm going to get plus the square root of 3. And that is my exact final answer with this one here. Now I'm just going to help you split up number 7, and then number 11 you can kind of work through that as well here. So if I've got 19/12, I'm thinking, hey, could I split that up into 9 pi over 12 plus 10 pi over 12, which will give me 3 pi over 4 plus 5 pi over 6. So that's kind of how I want to get this thing split up. This would be one way. So kind of go from there and finish out that process here. These do take a bit of time, just to warn you. Just be persistent and get them done. Next problems here are kind of doing the reverse of what we did here. We look to see if we have a pattern that kind of goes with one of our addition or subtraction formulas, and this one is sine addition. So I'm simply going to say, hey, I can add these two angles together into the sine function. That's going to give me the sine of 45 degrees. And we know that the sine of 45 degrees is going to be root 2 over 2. So here's the exact value. And then here's the trig function as a single of one number. So we're done with this one here. Now here looking at cosine plus sine, so this is going to be my cosine subtraction because of the formula. So this is going to be 3 pi over 7 minus 2 pi over 21. Now I've got to do a little fancy work here to get this, so I've got to get a common denominator so I can get these combined. So I got to multiply by 3, and that will result in cosine of 9 pi over 21 minus 2 pi over 21. This becomes 7 pi over 21, which gives me cosine of pi over 3. So there's my single. And what is the cosine value at pi over 3? It's going to be 1/2. And then finally, we've done a sine, we've done a cosine. Of course, it makes sense that we'll have a tangent 1 involved here. So looking at this, this does set up to be a tangent in terms of whether it's adding or subtracting. Since there's a minus on top, that means it's a subtract. So I'm going to say, hey, I'm just going to take the tangent of 73 minus 13, combined angle there, which is going to be the tangent of 60 degrees. And the tangent of 60 degrees is my one answer. And again, with the newly denoted, documented tangent values around your unit circle, this should be root 3. Moving on here. So again, we have a number of these additional problems as we kind of work through here. Again, I'm going to work on maybe one per screen here, just to kind of show you what goes on here. Again, these are a little bit unusual, but let's go ahead here. We are just proving a cofunction. So again, we know that cotangent is going to be cosine of this angle subtraction over the sine of the same angle subtraction here. And then from here we expand using our subtraction formula. So cosine is cosine pi over 2 cosine u plus sine pi over 2 sine of u. Write small, you're going to run into the other problem. Down below, we're going to get the sine of pi over 2 cosine u minus sine minus cosine, pi over 2 sine of u. Now we do have some definite angle measures here that we can evaluate here. Cosine of pi over 2 is 0, so all this cancels. Sine of pi over 2 is just 1, so I get sine of u left over on the top. The sine of pi over 2 is 1, so on the bottom we're for sure going to get this. And the cosine of pi over 2 is 0, so all this cancels. So we get sine of u over cosine of u, which is tangent u, and that matches these. Okay, similarly here, just like we did previously here, we have to get the one side equal to the other. So I'm going to take a look here at number 26. Looks a little different. So again, cosine subtraction is going to be cosine x cosine pi plus sine x sine pi. I'm just doing the left side here, and again, since I do have some radian values here, cosine of pi is -1, so this comes out to be negative cosine x. The sine at pi is 0, so all this cancels, and we are done. So that one kind of simplified quite easily here. Moving on here, let's take a look at one of these that works out. Let's take a look at 30. We haven't done too much with tangent here. So again, I'm going to simply work on this left side for starters. Remember, we can get the left side to look like the right side, we can get the right side to look like the left side, or we could work on both sides to get them look the same. So with this one, this is tangent subtraction. So I'm going to say, hey, I got tangent x minus tangent pi over 4. And then in the bottom I get 1 plus tangent x tangent pi over 4. So I'm just going to double check here. I've got that subtracting to that. Okay. So now I do have some simplifiable tangent expressions here. So tangent value here is going to be 1. Here, this is also 1. So when I rewrite this, I get tangent x minus 1 over 1 plus 1 just tangent x. So that's simplified. This matches that, and we're done. So again, these go not too bad as you kind of get going here. This one, we'll go ahead here and just apply both the cosine addition and cosine subtraction. And as we do that, we'll see what happens here. So first of all, I'm going to have cosine x, cosine y, minus sine x, sine y for this first one, plus, I'm going to change colors here. I'm going to do the same thing but with the subtract, so cosine x, cosine y, plus sine x, sine y, and that equals that right side here. Let's see if we can do any simplifying here. I've got this guy, I've got additive opposites here, so these cancel. And now these two are identical, so I get 2 of them, so I get 2 cosine x, cosine y. That matches that, so I'm done with that one here. Number 34 here, I worked through it previously. I had a typo. I did not include the minus or the plus sign in the denominator on the right side. Caused me a little bit of pain and suffering, but fixed it. And now we're ready to go here. So the key thing here is probably working on both sides to see what we get here. So first of all, cotangent is going to be the cosine of over sine of the angles being added. Okay. And then over here on the other side, I'm going to just kind of convert this all into cosines and sines. So this is cosine x, sine x, cosine y, minus 1 all over cosine x, sine x, plus cosine y, sine y. So a lot of room you have there. You might need most of it here. So now, keeping the equal sign maybe over here, I'm going to go ahead and expand these out here. Not much more I can do with that one here. Over here, though, oh, this is an x here. So first of all, I'm going to get a common denominator in the top of sine x, sine y. That means I just multiply by numerators up here. So I'm going to get cosine x, cosine y, and then minus gets the full denominator, so sine x, sine y. In the bottom, we get a common denominator that's the same. And again, as I adjust, I'm going to get this sine y plus sine x cosine y. Now, I do have some simplifying I can do here. Since both top and bottom on this right side, these can cancel. And if I take a look here, this piece matches this piece. This piece matches this piece. Up in the top, I got this piece matches this, and this matches this. So I'm done. Okay. So, really getting used to writing out and evaluating using the addition and subtraction formulas for sine, cosine, and tangent. Over and out.